Hello, this is Dr. Lori. In this next video, I would like to show you the magic that can happen when we combine what we've just been learning about cohort studies with a previous study design we've looked at, which is the case control study design. And this is actually a very powerful combination because even though the analysis might be a little bit more complicated, it gives us a lot of data around a really wide variety of possible outcomes. So let's take a look at some of the similarities and differences and how those two study designs are actually combined. So in terms of being similar to a cohort study, we start off by looking at a population. We have a target population in mind, and from that target population we draw a random sample. So this is exactly like we've done in a cohort study before. And then at baseline, we measure lots of different kinds of exposures, possibly by interviewing people or physical exam, lab studies, imaging, all that kind of stuff. So we collect all these exposures, and then, as always, we follow them forward to see if that particular outcome happens. And remember, this happens over time. And so this is considered to be a prospective cohort design. But then, once we get, here's time. Once we get out here, so to speak, and we have some information about some of the outcomes, we may have some additional questions that a case control study design would be best to answer. So I'll give you a scenario from the Adventist Health Study. Basically, we did this. We collected baseline data and then followed them forward for several years or decades. And we found out that certain people seemed to be more at risk for fractures. And we wanted to be able to look at that relationship, but we knew that we could only conduct these bone density scans on a certain number of people. Every time we did this bone density scan for the purpose of this study, let's say it cost $100. Sometimes the kinds of things that we're interested in cost thousands of dollars. And so in order to find out about this outcome definitively, we would have to do this very expensive test. Now we have a lot of baseline data. Adventist Health Study, you may be aware, has hundreds of thousands of people in it. So for us to conduct this particular scan on every single person would be very prohibitive. So instead, we collected a group of who we considered to be the cases of this particular disease outcome measure that we were looking at, and we did the bone scan on that particular group. And then we collected, out of the people who did not have the outcome, in other words, they were controls, we selected a sample of them, and we conducted the same bone density scans. So we selected people with and without the outcomes. With the outcome, those are called cases. Without the outcome, those are called controls. And so then here's our new study group. We have cases and controls. Obviously, these people that don't have the outcome also came from that particular study. But we only selected a certain number of each one of those to compare with each other because that particular test was so expensive to do in our whole entire cohort. So that's one of the kinds of things that we can do. Another thing that we can do with this combining the cohort and case control is we can look back at certain exposures that at the time either didn't exist or would also be very expensive to do. And so let me give an example. In Adventist Health Study again, what we did is we collected blood samples, a variety of blood samples and subcutaneous fat samples, and we said we don't know every single test that we're going to want to conduct 10 years from now, 20 years from now, as time goes by. So let's just store these frozen. Maybe those particular lab tests don't even exist yet, but 10 years from now they will. And so we store these samples that have the exposure hidden in them. But we just don't know what the measurements are yet. And then let's say we get somewhere out into the future, we do another case control study. We collect some cases, we collect some controls, and then we only pull their frozen tissue or blood samples out. This is especially helpful if those kinds of tests are still experimental or in the early phases and they're expensive. We don't have a cheap way of doing those. And so if we have to look back at whether a person was exposed or not, we have the sample from back then because we stored the blood a long time ago, but we haven't actually run it through the machine to test the levels yet. So those are a couple of examples where this nested, so within this random sample, we have a nested group of cases and controls that we pull out, only a few, to be able to do this particular study. Now, one of the big benefits of this is that for a whole bunch of other exposure variables, let's say age or gender or race, ethnicity, those were, and even other patient-selected, dietary patterns and exercise and occupation, those are all determined at the beginning of the study. And so we have a ton of data that is already existing that we can add some of these possibly more expensive pieces to, but we don't have to collect all the data that is needed in order for us to compare these cases to these controls. So that's called a nested case control study because it takes a case control study and it nests it inside of a cohort study. We already have that group in our data set, and so then we can draw from that particular sample that we already have in order to find our cases and find our controls. So that's a really neat study design that you might hear about, or that may be included on CPH testing in the future. It's less common because most of the questions that we can answer don't have these limitations where it's extremely expensive or we didn't have access to it at the beginning of the study. So in that case, we would just use the whole entire cohort. We have all the data, so why would you only use part of it? So that's a summary of the nested case control study.